So we are on logarithms page 2. We're doing the first example. It gives us log of x is equal to 0.3. Now, it is understood that whenever it just says log, it's automatically base 10. I'm not going to write it in there, but I need to do the lean to because I need to be able to find x. So I need to get into exponential form. So I'm going to lean to the left, and the furthest thing on the left is the 10, even though you can't see it. I'm going to lean to the right, that's going to be my exponent, equals the middle. Get it right. Now the way you're going to do this is you're going to take this lovely calculator and you're going to plug in 10, raise it to the 0.3, and you get some big honking number, and we're going to say x is approximately, because we're going to have to round it, 1.99526, da da da. Okay? So far so good? Alrighty. We're going to look at our next example, which says 5 equals 3 parenthesis 10. What did they raise that 10 to? I can't see. X. Okay. Now, it's hard to solve for the x in the exponent. That's why we have log, so we can get it out of the exponent. But before we do that, we want to make sure that this exponential part is isolated by itself. It's being multiplied by 3, so the first thing I'm going to have to do is divide both sides by 3. Okay? Can you see that this x is not affecting this 3 here? Okay, so that's why we need to do that first. So I end up with 10 to the x equals 5/3. And I'm going to put my exponential side on the left-hand side so when I do my lean to, I get it right. Okay? I'm going to lean to the left. What do I see?
10.
10, so I can put log. I know it's base 10. Lean to the left, get 10. Lean to the right, get 5/3 equals x. Log base 10 of 5/3. Again, you're going to use your calculator. And we would type in log, and we're just going to put in 5/3 because the calculator knows it's base 10. And when you do this, you're going to say x is approximately. Make sure to use the approximate wiggle because you do not want to say equal to. 0.2218487 da 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 da. Okay. Whenever you're given long numbers, you want to give a lot of decimal places. Okay, because you can see how long they go. Just give me a whole bunch of information for now. Okay? Okay. All right. Why don't we kill that? That way it'll make... All right, we're on our third example on page 2 on logarithms, and this is a log of a different base. And so, since our x is here in the middle, we're going to go ahead and put it in exponential form. And so we're going to lean to the left, and what's the first one you see? 4. 4. And we're going to lean to the right, and what do you see there?
2.
2. And that's going to equal the middle. Okay? And at this point, what I want to do is...
divide both sides by 3.
Exactly. Divide both sides by 3. So I'm going to end up with x is equal to 16/3. And I'm good with that. I don't need to put that in a decimal or anything. That's an exact answer. I'm fine with that. If you wanted to put it in a decimal, just make sure you use the repeating symbol. Okay? Our next example is going to be log of x plus 2. And the x plus 2 is in parentheses, so the logarithm affects everything inside there, equals -0.2. So far, so good?
Yeah.
Now, what is the base of this log? It doesn't say, but you should know.
10.
10. Whenever it doesn't say and it says the word log, it's automatically base 10. So if you lean to the left, it's going to be 10. Raised to the -0.2, so lean to the left, lean to the right, equals the middle.
Yep.
All right, so let's go ahead and use the lovely calculator to find 10 to the -0.2. And I got a big honking number. I got 0.630957, yada, 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 yada. Now, did I not do that right? 63097, that looks right. Equals x plus 2. Now, at this point, I'm going to take away 2 from both sides, so I get x is equal to, and I guess I'll probably put an approximate because I'm going to be rounding. So let's see, take away 2. -1.36904, 36904, yada, yada, yada. Okay with that?
Uh-huh.
All right. good. Just leave it going for now.
Okay.
Those went pretty fast. 10 raised to the 2x is equal to 20. Remember, you either want the log or the exponent on the left-hand side when we're doing this. We are going to do our lean to. When we lean to the left, what base do we have?
Log.
10.
10. So
Oh.
you could either write it log base 10 or just put log. Lean to the left, lean to the right of 20 equals the middle, so equals 2x. At this point, a lot of times I go ahead and do the divide by 2, so I get x equals, and then I'm going to plug in this log 20 and then divide by 2 all at one time. And I'm going to round it, so I'll say x is approximately, I got 0.6505 1499, yada yada yada. How did you do? Is that what you got? So far so good? All right, this is just a lot of solving for x's. All right? All right, let's go ahead and kill that. And we'll